Hi followers of Neuro Takeaway. This week we are going to resume the presentation of the highlights of the Movement Disorder Society Congress, which took place last month virtual, always in relation to neuroimages. Okay, here we have another exciting conference by Professor Alain Daguerre from Canada. He spoke about computer models of Parkinson's disease. At the upper left, we have the seminar paper by Professor Stanley Prusiner, who is a Nobel Prize winner. He, 20 years ago, proposed the exciting theory that neurodegenerative diseases were caused by proteinopathies, and the mechanism of propagation was Prion Lag Mechanism. At the lower left, we have three graphs showing the proposed mechanisms of propagation, for example, of Alzheimer's disease by tau or beta amyloid propagation. Then we have the frontotemporal dementia disease and lateral amyotrophic sclerosis by another. They have several proteins involved, but for example, TDP43 is one of them. Finally, Parkinson's and dementia, Lewy body dementia, and multisystemic atrophy by alpha-synuclein. And on the right, we have three proposed timescales of synapses and mechanism of propagation of information, because in the end, this is information. One of them is by neurotransmitters as glutamate and GABA, which can propagate by modifications of ions at the postsynaptic levels. Then we have another neurotransmitters as dopamine or acetylcholine that induce modification by second messengers. And finally, the mechanisms of transferring of information through proteins. This is a slow mechanism that can last a lifespan, and normally apparently is used to the maintenance of the network, and when it's altered, when there is a misfolded protein, this misfolded protein can be transferred to the postsynaptic level, and by a ripple effect can propagate the disease downstream. Well, here you can see some interesting concepts that help explain the mechanisms of computational models of Parkinson's disease. Here you have at the top left side the stages of Bragg's, and in this case the relationship of each stage with the manifestations of this process. For example, stages 1 and 2 are related to autonomic and olfactory disorders, stages 3 and 4 with motor and sleep disorders, and finally stages 5 and 6 with cognitive and behavioral alterations. At the bottom left, there are two disruptive quotes, one by a mathematician, an American mathematician, who was Norbert Wiener, and he stated that most mental disorders, especially schizophrenia, are produced by disruption of networks, brain networks. Then the other quote was by a writer, James Gleick, who said that the telegraph wires do not transport electricity but information. Then at the upper right corner you have a historical reference by that explain how a British physician, Dr. John Snow, in the 19th century, during the cholera epidemics, he could demonstrate it, and he traced the origin of the plague to a water pump in Broad Street. and they could fix that pump and stop the dissemination of the plaque. Finally, we have in the bottom right side another interesting concept. In this case, Dr. Duncan Watts, he said that a very small shock in a network can produce a very huge damage, and that depends on the quality, the vulnerability of the node that is affected, which in the brain is usually related to polygenic patterns of inheritance, and at the same time with the connectivity of this node. And this concept is applied to every network, and of course is equivalent to what happens in the brain. Well, here we have the technical aspects of this investigation of the group of Daguerre and collaborators. He used an MRI technique which is known as deformation-based morphometry, and with that they can assess the atrophy of the brain, of different parts of the brain. At the bottom left corner you can see the correlation, the comparison between Parkinson's patients and controls, healthy controls, and the only network that differentiated these two groups was the network of the substantia nigra and basal nuclei. And on the other side, on the bottom right side, you can see the comparison of this network based on atrophy with magnetic resonance connectivity by functional MRI of resting state networks, and there was a very similar pattern of connectivity between these two techniques. Here you can see the core of this investigation. They showed, or they plotted the atrophy of different parts of the brain against the physical distance and the connectivity to the substantia nigra, and he could demonstrate that the connections, the connectivity factor was more important than the physical distance. And so they studied then the main propagator, investigating different areas, and they showed that the substantia nigra again was the best propagator. This does not mean that the origin of the process is there, but it is like a very potentiated factor, and that has to do obviously with the content of alpha-synuclein at that level. Well, here we have the two main theoretical processes that can explain Parkinson's disease. One is the Prion Lag mechanism, where a misfolded protein can be transferred from one neuron to other, and with a ripple-like effect can produce aggregates of more misfolded proteins, and finally it ends up with the death of the neuron. And the other mechanism is the selective vulnerability of certain areas of the brain, and this is due to different genes expression at different levels, and these two mechanisms are not mutually exclusive. Well, and here we have the conclusions of this talk. Basically, we can say that brain networks, the connectomes, are the normal routes by which the brain works. On the other hand, some diseases, some neurodegenerative processes can propagate by these routes. And there are two main factors, mechanisms by which Parkinson's disease can disseminate. One is the Prion Lag pattern of dissemination by misfolded proteins and a ripple effect, and the other is the vulnerability, selective vulnerability of certain nodes of the brain that is determined probably by genetic factors. And then there are many questions to be answered. We have to know what role these proteins have normally in the brain, what information they take. Then we have to establish what are the factors that determine the connectomes dysfunction and the selective vulnerability of certain areas, and finally the possible relationship that might be between different proteins, for example between tau, TDP43 and alpha-synuclein.